Hello students, this is Guru from videoguru.in. Today we are going to learn how to calculate effective resistance. Effective resistance. You must have come across this term in your chapter Electricity in Physics. Once we'll go through the theory of effective resistance, then we'll follow with some examples. Okay, so let's start. Students, you can see I have drawn two circuits over here, the circuit 1 and circuit 2. Let's analyze this circuit first. See, you can see that we have a battery attached to the circuit, say it is of V volt, and we have three resistors, say R1, R2, and R3. Now, the value of R1, R2, R3 are in ohms, and it is not necessary that value of R1, R2, and R3 are equal. Okay, value of R1, R2, R3 can be anything. R1 may be 1 ohm, or it can be 100 ohm, or anything. Okay. And in this circuit also we have a battery of say V volt, and then we have three resistors, say R1, R2, and R3. Now you can notice that in both the circuits we have one battery and we have three resistors here also, three resistors here also. But still there is a lot of difference between both the circuits, and now we are going to understand what that difference is. So let's analyze this circuit first. Here in this circuit you can see that this resistor R1, one node of R1 is connected to battery, another node of R1 is connected to a resistor. Now if we talk about this resistor R2, then you can see that resistor R2 is connected to a resistor R1, and it is from another node it is connected to resistor R3. And R3, one node of R3 is connected to R2, and another node is connected to a battery. Now suppose a current of value I has been drawn from this battery. Okay, this battery is drawing I current. Now this current will flow from here, it will move then here, and then it will go through the resistance R1. But the value of I will remain I only. The same current will flow through R2 also, and the same current I will flow through R3 also, and the same current will go ahead to the battery. So in this circuit you can see that if I current is drawn from the battery, then all the resistors which are connected to each other, the same current I will flow through all of them. Okay, now let's talk about this circuit. Suppose here also I current has been drawn. Now this I current will flow here, then it will go here, and then it will go here. At this point the current I will see that it has three paths, it has three wires. Now where will current I go? Now the current I has to bifurcate into three parts. It has to divide into three parts. One of the part of I will go in this wire. Another part of wire I is current I is going to go in this wire, and the third part of current I is going to go through this wire. Suppose through this wire the current that has been flown is I1. Through this part the current has been flown I2, and through this part the current has been drawn I3. So here we can see that current I has been divided into three parts. Now through resistance R1, I1 current is going to flow. Through resistor R2, I2 current is going to flow, and through resistance R3, I3 current is going to flow. And past them here also I1, I2, and I3. At this point all the three currents are going to combine, are going to merge with each other, and again the current I will be flowing through rest of the wire. So what's the difference over here? Here we saw that the same current flows through all the resistors, whereas in this case different current flow was flowing through different resistors. So students, due to this difference we can divide our circuits into two parts. In some circuits resistors are connected in series. Here we can see that it is a series of resistors, one after one after one. So here this is called a series connection. And here we can see that all the resistors are connected to each other in parallel. So it is called a parallel circuit. It is called a parallel circuit. Now in the beginning it is quite confusing for everyone to detect in a circuit that whether the resistance are connected in series or whether they are connected in parallel. But after practicing a few questions, you will be very familiar with all these terms and all these figures and all. So until now we discussed about series and parallel connections of resistors, but now we will talk about calculating effective resistors. Okay, but before that we must understand what is effective resistor. So students, before we start our calculation of effective resistance, we first need to understand what is effective resistance. We have already seen this example. We have already seen that here three resistors R1, R2, R3 are connected to a battery. Here we have another circuit. In this circuit we have only one resistor, and that is also connected to a battery. Now suppose that these three resistors R1, R2, R3, all these three are drawing current I from this battery. Okay, and here this resistance R, this individual alone is also drawing current I from this battery. So it means the combination of R1, R2 and R3 is effectively same as the resistance R. It means we can replace R1, R2 and R3 with its equivalent, which is the resistance R. It means effectively both these circuits are same because both of them are drawing I current from the battery, and replacing of R1, R2 and R3 by a combined resistance R won't make any changes at all. So the effective resistance of these three resistors is R, because if we replace them with a single resistance, then also there is no change in the circuit. So this was the case of series circuit. Let's talk about parallel circuit also. In this parallel circuit, we have our resistances R1, R2 and R3. These are connected in parallel. Now if we replace this whole parallel system with an resistor of resistance R, such that the current drawn through R1, R2 and R3 from this battery is same, then it means that even if we replace the whole system with R, then also effectively there is no change in the circuit. So effective resistance of R1, R2 and R3 is R, or R is an equivalent of R1, R2 and R3. Sorry, R is equivalent of parallel connection of R1, R2 and R3. I'm assuming that you have understood all the theory. Now let's start with some very basic questions. Now suppose we have a question. Okay, here we have a battery of V volt. It may be any volt, it doesn't matter at all. Now the resistance R1 and R2 and R3. Suppose the value of R1 is given as 5 ohm. The value of resistor R2 is given as 5 ohm again. And the value of resistance R3 is given as 10 ohm. Okay, we have to find effective resistance. We have to find a resistance. We can replace these three resistors, and instead of that place we can place only one single resistance. Here we can clearly see that we have already discussed that these three resistances are connected in series. So students, whenever you see resistances connected in series, then all you have to do is you have to write R equivalent, and which will be equal to sum of all the resistors that were connected in series. Here R1, R2 and R3 were connected in series, so R equivalent will be R1 plus R2 plus R3. So R1, the value of R1 is 5 ohm, it's 5 ohm. The value of resistance R2 is 5 ohm again, and the value of resistance R3 is 10 ohm. Okay, so we get 5 ohm plus 5 ohm is 10 ohm, 10 ohm plus 10 ohm is 20 ohm, 20 ohm. So if we draw this circuit again, and instead of these three resistors we place only one resistance R of value 20 ohm, then that circuit and this circuit, both the circuits are one and the same thing. There's no difference at all. Let's see some more questions. Here in this circuit we have four resistors, 1, 2, 3 and 4. Are these connected in series? Obviously they are connected in series. If the current I will flow through the battery, then the same current will flow through this, same will flow through this, same will flow through this, and same will flow through this also. Now what will be the effective resistance, or what will be the equivalent resistance of this? So R equivalent will be equal to sum of all these resistors. So it is 2 ohm plus 3 ohm plus 5 ohm plus 10 ohm, and which will be equal to 3 plus 2 5, 5 plus 5 10, 10 plus 10 20 ohm. Again the answer is 20 ohm. Now let me make some changes in this circuit only. Now I have added two more resistors. One is here and another one is here. See, this one is 20 ohm and this one is 40 ohm. I have added two more resistors in the circuit. The equivalent of all these circuits, all these resistors is 20 ohm. And I have added two more resistors. One is this one and another one is this one. Two more resistors to this circuit. Now, are still all these resistors connected in series? Yes, they are. And how am I saying that? Because the same current, still the same current is flowing through all the resistors. Even if two more resistors were added, still the same current I is flowing through this resistor also, this one also, this one, this one, this one, and this one also. So what will be the new equivalent resistance? So let me cut out this one. The new equivalent resistance will be 2 ohm plus 3 ohm plus 5 ohm plus 10 ohm plus 20 ohm, 20 ohm plus 40 ohm, 40 ohm. And the final answer will be 3 plus 2 5, 5 plus 5 10, 10 plus 10 20, 20 plus 20 40, 40 plus 40 80, 80 ohm. This will be our new equivalent resistance, which means that if we replace all these resistors with a single resistance of 80 ohm, then that circuit, this circuit will be exactly the same. Now I think that we have done enough practice on series circuits. Now let's move on to parallel circuits. Now suppose we are giving this circuit where R1 equal to 3 ohm, R2 equal to 6 ohm, R3 equal to 12 ohm. Now we know that these three resistors are connected in parallel. Okay. Now we need to find out a resistance which can be placed at the place of these three. To find the effective resistance when the resistors are connected in parallel, you need to do this. You have to first write down R equivalent, 1 upon R equivalent, and that will be equal to 1 upon the first resistor R1, R1, and the second resistor and the third resistor. Okay, so you will be adding all of them, but before adding you need to reciprocal them. Reciprocal of R1, reciprocal of R2, reciprocal of R3. Simple. So the value of R1 is 3, value of R2 is 6, and value of R3 is 12. Here we have to take LCM, and the LCM will come out to be 12. And here we will be having 4, here we will be 2, and here we will be having 1. So we have 4 plus 2, 6, 6 plus 1, 7, 7 upon 12. So the value of 1 upon R equivalent is 7 upon 12. But what will be the value of R equivalent? What will be the effective resistance in this case? The effective resistance in this case will be reciprocal of this one. Obviously we are going to reciprocal R equivalent, so we will be reciprocaling this one also. So we get 12 upon 7 ohm. This is a simple mathematics that I'm not going to discuss over here. So here we have taken example of 3 resistors. Suppose if there were 20 resistors given in parallel, then in the similar fashion you are going to write down 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4 plus 1 upon R5 plus 1 upon R5, R6 and so on till 1 upon R20. So students, we have learned to find out effective resistance of a series circuit and a purely parallel circuit. But sometimes we are given a mixture of both. Suppose we have this circuit now. Okay, in this circuit you can see that R1, R2, R3, these three are in parallel connection. Whereas this circuit, this resistance, is connected to this network of parallel circuit. So what we do now, it's really very simple. It's almost same as previous question, just a little variation, and that's it. Now suppose we have this resistance and we have this battery. This is the resistance R4. Okay, we have just find out in previous question that equivalent of these three resistors is what? Equivalent of these three resistors is 12 by 7 ohm. Okay, so we can replace this whole circuit, these whole three lines and all, with this equivalent resistance of 12 by 7 ohm. Okay, and we can complete our circuit. Here we have R4 equal to 2 ohm. Now you can clearly see that this R4 and this 12 by 7 are in series. These both of them are in series connection. So what we have to do to find out equivalent of series connection, we have to just simply add both the resistance. So our equivalent of this circuit will be 2 ohm plus 12 by 7 ohm, and which is equal to 14 plus 12 divided by 7, which is equal to 26 by 7 ohm. I hope you have understood the effective resistance of a series circuit, the effective resistance of a parallel circuit, and effective resistance of mixed circuit also. Now students, we can go in this topic very deep, very deep. We can solve numerous questions. We can solve many types of questions, and we can see many tricks to solve those questions. But right now in this video, I'm not going to discuss all those things. If you really want to see those videos recorded by me, then you can post it to me on the comment section here on YouTube or on my website also, which is videoguru.in. And if really get requests from you people, then I'm surely gonna record those videos also. Thank you for watching. Goodbye.